or not? Okay, there we go.
Oh,
All right. So hello, good afternoon, good morning, good evening, everybody. Welcome to the Evolution and Maintenance 4 session. We have, so I'm Sarah Nedi from the University of Alberta, and I'm here with Henry Tang, who's also from the University of Alberta, our student volunteer for this session. And we have 6 talks. Each talk will be 5 minutes. And we're going to go by the order on the researcher homepage, so on the official ICSE program. We'll have one clarification question after each talk and keep longer discussion questions till the end. So our first speaker is Jiaqi Chen, who's a professor at Sun Yat-sen University in China. So go ahead.
Hello everyone. Yeah, my name is Jiaqi Chen, and I'm assistant professor in Sun Yat-sen University. This paper named Maintaining Resilience-Related Concern for Post-Deployed Ethereum Smart Contract Deployment was accepted by IMSI. And this was when I was a PhD student in Monash University. There are 2 research questions in my paper. In first research question, we investigate what kinds of maintenance issues will smart contract developer encounter. And in the second research question, we inform readers what are the current maintenance methods for smart contracts. This is the overview
of the methodology we use in our paper, which consists of 2 phases. The first phase aims to find the preliminary answers of the 2 research questions. The second phase uses a survey to validate the answer we collected on the first phases. Based on the 2 phases analysis.
We first conduct a semantic literature review to find the preliminary answer of the research question. To find related literature about smart contract maintenance, we use keywords to obtain about 1,000 initial smart contract related papers from 5 research engines. Then, based on 6 rules, we manually read the abstract of these papers and conduct a snowballing step to enlarge the paper list. Finally, we totally obtain about 131 relevant papers. Then we carefully read all of these papers and use card sorting to find the answers of the first research question and the second research question. Since smart contract is fast evolving, some answers we found from literature might out of date. Besides, there might be gaps between industry and academia. Thus, we also design a survey to validate our findings in phase 2. We totally received 165 responses, and based on our feedback, we finally found 13 maintenance issues. 13 maintenance issues about smart contract. For
the 13 maintenance issues we found, we divided them into 5 groups according to the 4 kinds of maintenance types. And some maintenance challenge appeared in all 4 kinds of maintenance. Thus, we divided them as maintenance issues. Due to the time limitation, I cannot introduce them all. So
now let's come to research question 2. We totally found 41 papers introduce methods to maintenance smart contracts. 31 of them are offline tracking method. This kind of method usually checks smart contract defects before redeploying smart contracts by using program analysis method. Online tracking method is able to maintain deployed smart contracts without redeployment. But most of them cannot be used directly. For example, one kind of online tracking method is batch code rewriting. The tool will check whether a smart contract contains related defects and then rewrite their batch code. However, this kind of method cannot be used now because this tool needs to be merged into Ethereum virtual machine. However, due to the high false positive of these tools, and they need to be modified the batch code, which obeys the immutability rules of a blockchain. so they are impossible to be merged into EVM in recent few years. Thus, the most popular method to maintain smart contract is offline checking method. Thank you
for listening. My talk is finished.
Awesome. You're even less than the 5 minutes. So are there any quick clarification questions? Okay, I have one, but I think it's more of a discussion question, so I'm going to keep it till the end. And we're going to move on to the next talk. So please queue up your questions. We'll have a bit of time for discussion at the end. You can put them through the question in the chat, as Henry mentioned, or when the time comes, you can just raise your hand or mention you want to have a question, and I'll call it. All right, so I don't know if our next speaker is here. Haiyu Wang for context-aware retrieval-based deep commit message generation. I do not see them. Okay, in the interest of time, I think we're just going to go to the third talk, and then hopefully the speaker is here and we can circle back to them. So Fiorulla, do you want to go next? Fiorulla, sorry. All right, while you screen.
Yes.
So Fiorulla is a professor in the University of Sanyu in Italy, and she's going to be talking about self-admitted technical debt.
Okay. Hi to everyone. I am
sorry, do you
Fiorella.
just want to go into presenter mode so we can see your transitions?
Actually, I am in presentation mode.
Oh,
Can you see?
We see your slides, so maybe you need to flip. Like we see, with the thumbnails and all.
Let me start again. What about now?
Yeah, that's good. Thank you.
Okay. Hi to everyone. I am Fiorella, and today I'm going to show our results of an empirical study aimed at comparing self-admitted technical debt practices between industry and open source. This study has been conducted together with the Eindhoven University of Technology, and this is a journal first paper. Indeed, our study has been accepted to Empirical Software Engineering in 2021. Before going on our study, it is important to conceptualize what is our context, and in particular, what is a technical debt. As being defined by Cunningham, it is not quite right code, which we postpone making it right. Built on top of this definition, Poddar and Shiab have introduced a new concept, namely self-admitted technical debt, identifying all those technical debt being intentionally admitted by developers by means of source code comments. Previous literature has already investigated what is the relation and the impact that self-admitted technical debt has on software quality. Also, there are studies investigating the developer's perception of technical debt, and also studies aimed at identifying what are the strategies related to their introduction and removal. However, to the best of our knowledge, there is a lack of understanding what are the main reasons and circumstances in which developers admit technical debt, and more important, how they cope with them. So we have conducted our study, and since that we want to focus our attention on the developer's perception and rationale, our study has been entirely conducted by simply relying on semi-structured interviews and surveys. So we have not conducted any kind of mining software repository study. Moving on, what are the main findings of our study? First of all, we are in terms of frequency of admission, what we found is that when looking at annotating the rationale behind design and implementation decision, both industrial and open source developers tend to annotate them with very similar frequencies. However, when we look at self-admitted technical debt, it seems that open source developers tend to admit self-admitted technical debt more. So what we suggest is that both industrial and open source projects try to find a kind of balance between the desire to ensure quality, but also promoting an open culture where the awareness of technical debt is actually encouraged. When we look at the reason why developers admit or not self-admitted technical debt, what we found is that developers believe to remember what needs to be improved. However, not taking trace of the decision rationale could create a track factor. So what we are suggesting is that developers try to consistently add self-admitted technical debt and at the same time document their design decision in order to promote awareness in the project and also try to support onboarding newcomers and reducing the likelihood of project abandonment. Another aspect that we have analyzed is related to what are the channels used for annotating. And what we found is that, kind of expected, source code comments together with the commit messages, pull request and issue are still are very common. However, there is a kind of huge percentage of both industrial and open source contributors that still rely on internal and private documents, hindering, of course, the awareness within the whole team. After that, what we have analyzed is the content of those annotations. And what we found is that self-admitted technical debt usually goes beyond simply maintainability and performance issue. And an interesting result is related to the fact that there is a difference between industrial and open source projects because open source contributors tend to annotate the need to change a particular API. And these results, our conjecture here is that probably open source projects are more likely to use third-party components, whereas industrial projects may be subject to more strict organizational policies, but also technological constraints. So here we ask the research community to provide recommender systems supporting developers in the choice of API for addressing self-admitted technical debt that may be related to API upgrade. And the final aspect that we have analyzed is how do developers react when they encounter previously introduced the technical debt comments when completing their development tasks. And kind of surprisingly, we found that in many cases, self-admitted technical debt are taken into account, but also addressed, but there are still cases where developers tend to hide them. On the one hand, there are cases where this behavior could be considered as legitimate, but there are also cases where this kind of behavior should be considered as a smelly behavior. And with this, actually, I have concluded my presentation, and I am happy to discuss about this in the discussion section later on.
Thank you so much. So if there's a very quick clarification question, because we are over time, let me pause for a second. Okay, I do have one, but I'm going to, yeah, okay, so Shane has one, but I think that's more of a more general discussion question. So I'm going to keep that till the end. Again, remember to queue up your questions. I'll take them in order at the end. And speakers, you can think about, how you want to respond to these as we're going on in the session. So let's go on to the next talk. So Sanis, are you ready? Oh, are we? Sorry, did I miss? Oh, sorry. You are absolutely correct. I missed the order.
Okay.
Awesome. You're ahead of me. Good. All right. So our
Okay.
next speaker is Lina Actua, who's a PhD student in Eindhoven University of Technology in the Netherlands, and she's going to talk to us about Breakbot.
Okay, thanks, Sarah. So today I will briefly introduce Breakbot, a bot for assisting library evolution. This is a joint work with Thomas Degel and Jean-Rémy Fayeri in France, and we submitted our paper to the NearTrack at ICSI. So Breakbot is a GitHub bot for Java projects. It analyzes pull requests, and it mainly looks for two things. The first one is the set of breaking changes that library maintainers have introduced in the pull request. And the second thing that it checks is the impact of such breaking changes on a list of client projects. This list depends on the library that we are investigating. And for now, it should be defined by the library maintainer. Just to see how useful Breakbot can be, let's see a real example. So in this case, we chose Spoon. Spoon is an open source library that analyzes and transforms Java source code. And basically here, what happened is that in September 2019, the library maintainers introduced new functionality. And with this new functionality, they decided to deprecate a set of classes, mainly the import scanner classes. So far, so good. This deprecation just labeled these classes to inform library maintainers that in the future they would remove the types. Then 3 months later, in December, they decided it's time to remove the classes, and they just take them out in this new pull request. But what happened here is that Spoon has this list of relevant clients that they are constantly monitoring, and they discovered that with this pull request, they actually impacted two different clients, and these clients were broken, mainly Astor and Despot. Those are the names of the client projects. After 2 months, they decided that the way to cope with this was just like restoring the import scanner classes. And yeah, with that, like the Astor and the Despot client projects compiled again. But then this was done at the cost of impacting the design of the library. So you kept like these obsolete classes, and the solution came quite late in time. So how does Breakbot help here? Basically, if they had Breakbot installed in their GitHub repository, they would have pinpointed the pull request that was being merged into the main branch. They would have used Breakbot and use it as a check on the pull request. And Breakbot would have generated like this report that you are seeing in front of you. So basically what we show here is first like the number of breaking changes that are being introduced in the pull request, the number of broken uses in client code, and this is like the locations that are being impacted, and the number of clients that are being impacted by the pull request itself. Moreover, you have the whole list of breaking changes, and here you can see that we are highlighting the class removed of the import scanner class, right? Then you have the impacted clients. Here we have Astor and Despot. If you want to zoom in, you can also check the whole list of clients. And here, for instance, for Astor, you can see that it is being impacted. That's why the status has a cross in front of it. And then you have the number of broken uses or broken locations. You want to check actually like the content of those broken locations. You can also zoom in into the Astor report. And then you will find out, for instance, in this case, that due to the removal of the import scanner classes, you have these two locations or uses that are being impacted. In this case, it's an invocation of the getAllImports method that was part of the import scanner class. And then the invocation of the constructor, the import scanner implementation class, right? So the big point here is that if they had breakbut back then, they would have like visualized what was coming, foresee what was coming, and make an informed decision about the changes that they were accepting in the pull request. For our future research plans, these are like the main 5 points that we have, but I will just discuss briefly two. The first one is investing some time on discovering like relevant clients, because right now we really need to write them manually. And the other aspect is checking the client side. And here we're talking about a Dependabot++, where you do not just suggest like the new release that has been introduced for a given library, but you also give more information to the user, such as which locations will be impacted, and if that makes sense or not to them to actually consider the new release of the library. So this is the title of the paper. You have the two URLs pointing to Breakbot and Maracas, which is the underlying tool that we are using. And please feel free to contact us if you have any other question.
Awesome. Thank you so much, Lena. Any quick questions from the audience? Yeah, so there is a question from Shane. Shane, if you want to unmute and ask it, feel free to do so.
So is the list of clients provided as an input to Breakbot? Yes, indeed. So the idea is that you will have a YML file where you configure Breakbot, and one of the things that you can configure is the list of client projects that you want to consider. You can also exclude certain parts of your API because maybe those ones are not relevant to you.
Awesome. Thank you so much. All right. So yeah, if you have more general questions, please put them in the question chat. Mention the speaker name. We'll have time for discussion at the end. All right, so our next speaker now in the correct order is Zanis. All right, are you?
Yes. So
okay, awesome. So while you share your screen, so Zanis Ali is a PhD student from the University of Luxembourg, and he's going to be talking to us about log messages.
Yes, so we submitted the paper in ICSE Trier technical track, and the paper its title is Guideline for Assessing the Accuracy of Log Message Template Identification Techniques. The other authors include Dom Wanchin, Domenico Biancoli, and Lionel C. Bryan. So basically, as we know that the logs are everywhere in your mobile phone and software systems, and they are the only data available that actually reflect the system behavior and are used for various software engineering tasks such as anomaly detection, model inference, or testing. Now, log-based analysis requires structured log as input, that is conversion of free-form messages to a structured log, as you can see here, and we will see in the future slides also. The template identification comes in handy when we need to have structured logs, so we have to have set of log messages as input, and that will convert into event template, that is a fixed token as well as a variable token. But the issue arises that most of the time we do not have the source code in hand, so template identification is the process that you need to use there. Now, based on the literature review, we have many template identification techniques already presented, as you can see here in this slide. But the problem that arises is that how we can assess the effectiveness of template identification techniques. And that is where the goal of the paper comes, that is to provide guidelines to assess template identification techniques based on the targeted or intended use case. Now, scope of the guideline includes these 3 points, that is accuracy metric, Oracle templates, and incorrectly identified templates that you will see in detail in the later slides. Now, basically, there are 2 different metrics that have been used, that is grouping accuracy and parsing accuracy in the literature. The issue is that both are sensitive to the number of log messages, as well as this is problematic if log messages are repeated, for example, heartbeat messages. For that, we proposed a new metric called as template accuracy. Basically, it considers correctly identified templates rather than the correctly parsed messages. That is the drawback of grouping accuracy and parsing accuracy. Now, based on the literature review, we've observed few issues. The issue number 1 that we observed is that results from different accuracy metrics are not properly compared. So for that, we provided a guideline to use a metric that adequately assesses the accuracy of template identification techniques in the context of the targeted use case. For example, 2 important criteria that you kept in mind for selecting the metric is, are the variable tokens required or not, as well as message frequency is important or should be considered or not. The second issue that we observed is that Oracle templates are not always correct, mainly when extracted using without the source code, having access without the source code. For example, if you look, log message status is false. Now, incorrect Oracle template could be status is false as a fixed token, although the Boolean that is true or false should be, or logically it is a variable token in the source code or the print statement. Now, the correct Oracle template here would be status is static or the variable token. So for that, actually the guideline include to use Oracle template correction, as the Oracle templates extracted without using source code are most likely incorrect. So for that, we actually provided many heuristic rules based on the manual investigation of the Oracle templates using this publicly available benchmark, that is LogHub. So basically, if you look at the simple example that is double spaces, what this rule does is it replaces double spaces with the single space. As an example, if you see we have double space variable token, it should be converted into the single space and variable token, and so on the other heuristic rules that you can find in the paper. Now, the third issue that we observe is that additional information about the incorrectly identified templates is not available, and it would be great to have that information. So the guideline for that would be to perform incorrect template analysis. So in order to understand in which way templates are incorrectly identified, we propose an analysis of incorrect templates. The basic idea is actually to consider template identification as the process of generalizing or generalization log messages. For example, if we have two messages that is retry 1 and retry 2, they both can be generalized as a single template that is retry static variable. Now, our analysis classify incorrect template based on the level of generalization as we provided above, that is overgeneralization, undergeneralization, as well as the mixed type. Now, based on the evaluation, if we look, we have 3 research questions. That is, how does the ranking of techniques vary when using different accuracy metrics, as well as what is the impact of Oracle template correction, and can the analysis of incorrect template provide any insight on improving the template identification technique? So how does the ranking actually affect is that the ranking of techniques vary a lot depending on the choice of accuracy metrics, as well as it is essential to use appropriate accuracy metric according to its intended use case. The second RQ would be the impact of Oracle template correction. So the Oracle template correction is important for properly ranking template identification techniques, as well as on average 28.5% of templates were incorrect. The last point is that different techniques have different percentage of overgeneralized, undergeneralized, and mixed type. So based on the result, the weakness of different template identification techniques can be identified. And based on that, I would like to wrap up the presentation. And thank you. If you would have any question, kindly let us know in the question section.
Thank you so much, Thanos. Any quick clarification questions? All right, so if you have longer questions, please put them in the chat. I will call them in order after we finish the talks, and we will have time for discussion. So hang around and think of your questions. All right, so our next speaker is Zili Ren, who's a professor at Dalian University of Technology in China, and talking about patching unreproducible builds. Right.
Okay.
You just want to go into presenter mode?
Okay. Hi. Can I be heard?
Yeah, you can go ahead.
Okay. Hi, this is Zili Ren from Dalian University of Technology, China. It's a great honor to present our work. So this study is about reproducible builds. A software build is reproducible if given the same source code, build environment, instructions, and user can guarantee bit-by-bit identical artifacts. Due to its wide applications, various repositories have been conducting their check, such as Debian, Guix, and Arch Linux. The validation workflow is as follows. It's generally multiple builds and compare their artifacts. The validation could be conducted automatically. Unfortunately, the fixing is mainly manually conducted. So towards the automated fixing of these issues, we have identified 2 major challenges, the localization granularity challenge and the historical knowledge utilization challenge. To tackle these challenges, we propose a novel approach for automatically generating patches for unreproducible builds. The solution features a system-level tracing monitor to gain the mapping between the invoked build commands with their location and the history-based patch generation. By comparing these two mechanisms, we are able to generate patches for validation. So here we present the framework RepFix. There are two major components in RepFix: the tracing-based fine-grained localization and the history-based patch generation. So we start with a normal build process, which is normally in user space. To capture more verbal information, such as system calls and runtime function calls, we consider a trace monitor. The trace monitor loads a tracing script, compiles it into a kernel module, which attaches probes to both the kernel and the user space applications. So when we run the build process, we could obtain not only the artifacts, but also the trace. With this as input, we could conduct the localization and get the accurate location of the commands for patching. Then we proceed to the patch generation. On the one hand, we extract the command for patching. On the other hand, we retrieve the most similar patch from the Debian's backtracking system and build a template. And we apply the edit operation of the template to the patch command for patching and generate a patched command, which is further used to build the candidate patch. And finally, we should validate the patch and gain the final result. In the validation process, we consider the following criteria. First, no artifacts are missing. And second, the patched source could generate bit by bit identical artifacts. Besides, we also conduct manual check for the final results because there may be false positive due to malformed patch. For the third part, the experimental results. Extensive experiments are conducted over a set of real-world packages to evaluate the effectiveness, the contribution of the components, and the efficiency of the RepFix. Also, we conduct a case study to investigate whether RepFix can be extended to other distributions. Finally, the conclusion. To the best of our knowledge, this is the first study to generate a patch for unreproducible builds in an automated paradigm. We propose a novel approach, RepFix, and we conduct extensive experiments over a real-world dataset to demonstrate the usefulness. For future directions, we're interested in generating fixing rules from existing patches. Also, we are interested in extending the techniques to other distributions and platforms. And thank you, that's all.
All right, great. So thank you so much. Are there any quick clarification questions? Okay, so we are missing a paper, so we actually have more time now for discussion. So I'm just gonna open it up for questions to all authors. So let's make this session interactive. If you wanna unmute, turn your video on, ask your questions, to each other. I'll just kind of try to moderate order, but feel free to, ask questions to any of the authors. So while thinking of questions, I'm gonna already start with the ones in the chat. So I believe those were, let me just check my notes, were directed at Fiola. So there was a question from Shane. Don't know, still around? I don't think so. Okay, so let me just read it up. Oh, he is here. Okay, Shane,
Hello.
yay, ask your question.
Hi, how's everybody? So yeah, I typed my question quickly and there's not really enough context to understand what I meant. So what I meant was, like, you found that the channel of communicating self-admitted technical debt was still dominated by comments rather than issues. And I found that surprising because comments aren't something that's being tracked as part of the backlog, for example, when you're planning releases. And issues are. So do you have any idea why developers are preferring to leave notes there?
Actually, when looking at the channels, we found that developers tend to use source code comment and issue together. So they try to use comment for locating the presence of the technical debt, while using the related issue to take trace of all the details related to the issue. And so this is the reason why source code comments are still used very frequently until now. And the other thing is that using source code comment can help in for what concern the onboarding of newcomers, in the sense that when we talk about with our interviewee, we found that newcomers try to kind of copy what has already been done. So they are still inheriting their behavior from what has been done in the past. So if they see people attaching the source code comments for pointing out the presence of self-admitted technical debt, they will try to do the same for new self-admitted technical debts. The last thing that we found when we asked a developer about what are the reasons why they do not admit at all self-admitted technical debt, what we found is that many open source and industrial developers point out the problem of having source code comments being not synchronized with code. So one of the problems of using source code comment is related to having comments being outdated with respect to the story being told by the code. Actually, this is what we found.
Great. Awesome. So there's another question for Fiora, but I'm gonna just switch it up. We'll get back to that one just to kind of go around for all speakers. So there's a question to Lina from Domenico. I don't know if Domenico's still on the call. Let me just quickly check. No, I don't see them. So, oh, they're awesome. It just magically appears. So, Domenico, do you want to ask your question?
Yes, actually, just to give you some context. So, you showed the use of Breakbot on GitHub, so with the open source libraries. But in the paper, you also mentioned the case of commercial libraries and clients. So the question is, if I want to deploy Breakbot as a library developers, but I have commercial clients where I cannot access the source code, will that be a problem? Do you have something in mind? I know this is early work, just to discuss the applicability of Breakbot in practice. Thank you.
Yeah, that's actually a great question, and for that one, actually, we had a discussion with Alexander Serebrenik about that, and he told us that the issue right now with research usually is that we are investigating a lot like open source projects just because we have access to them, and then we are just keeping aside like all these commercial projects because it's more difficult to have access to them, right? And regarding like the question you are asking me, we would like also to use all the capabilities of Breakbot also in this commercial context, but definitely like accessing all these projects which are proprietary, it's an issue, right? So in that case, what I can imagine is just like, this is not like a technical issue because that one can be overcome. It's more like a cultural issue that we need to find out how to handle. And this will depend on each project that we are considering, right? So I do not have like a precise answer to that, but of course we would like also to include these libraries and these type of clients in the radar, right?
Thank you.
Okay, awesome. So just a reminder for people to put questions in the chat. I will circle to the remaining one. But in the meantime, I had a question for Schiacci. So for the smart contracts paper. I might be pronouncing the name incorrectly. So is he still here? Yes. Probably. Okay. So I guess, yeah, connection issues not there. Okay. So then maybe we can circle back to the question that's already in the chat. Timer had a question. Timer, you're still here if you want to ask your question. This was also for Fioruola.
Hi, can you hear me okay?
Yeah.
All right. So my question is that how does something, or did you observe anything showing like how, for example, if I'm a developer that works on both an industry project and an open source project in my own time, do things like code review or the way other people also evaluate my code come into play in the way I view technical debt? Because I would imagine that a code review would make more people feel that there's no technical debt, or they may try to minimize technical debt from even occurring.
Actually, yes, good question. What we found is that in particular for industrial developers, they tend to, they have kind of fear of admitting technical debt in order to let others know about the misbehavior being probably introduced in the code. And the same, of course, does not appear in open source projects. And when we asked about specific annotation policies, what we found is that in particular for industrial developers, there are specific guidelines hindering them to push comments such as to do fix me when they have to release on the main development branch. So they want a stable release branch and probably use technical debt only when developing. So there are some policies making the rejection of pull requests containing those kind of comments actually. And this is especially true for industrial developers based on our results.
Okay, thank you very much.
Awesome. So switching it up a bit, I have a question for Zanis. Don't know if you're still here. Yeah, I can see. Awesome. So my understanding is that you were coming up with these guidelines, right, to extract templates from kind of unstructured log messages. I might have missed it in your talk, but how did you evaluate those guidelines? Like you mentioned there's existing techniques. Do you try to evaluate if your guidelines would apply to them, or just in general?
Basically, we had 14 techniques, and 14 techniques basically, as I showed in the presentation, as well as we had many data sets, around 16 data sets. So we have actually evaluated our accuracy metric as well as the other accuracy metric in comparison with on those 16 data set as compared to 14 techniques, and provided the results in depth. Yeah.
But is the idea like, because you're creating different metrics, right?
Yeah, it's a new novel metric. Yeah.
So then, like, are you checking? Let's assume that the previous technique said, hey, we have very high accuracy or whatever metric one, but like it was a high number. Are you checking that your proposed metrics is also providing a high number? Because in the end, like you're and oranges, right? Because they're not the same metric.
Yeah, basically,
so is it just looking at the direction, kind of?
Sure. Yeah, basically our approach was not to show that our accuracy metric is too high also like that metric, but to show that there is limitation because they provided in their metric very high score, while it should not be if you compare it correctly in the intended use case. So that's what we showed as a drawback of older metrics with our metric.
Yeah, I mean, if I just add one more point, I think the guideline is basically to tell them there are different metrics, different accuracy metrics, and there are different techniques. But the problem in the existing literature was they don't even clearly understand what metric to use to compare different techniques, different template identification techniques. So what our guideline does is basically providing some criteria when for certain application, what kind of accuracy metric must be used given that some circumstances. That's kind of one guideline we are proposing, and what we have evaluated is that in fact using different accuracy metric can result in very different rankings of the existing techniques, which means that choosing an appropriate metric is really important indeed. Yeah.
Okay, cool. Thank you so much. So there's actually another question to Zanis from Lena, and then there's a question for Lena. So Lena, do you want to ask your question, and then we transition to the question to you?
Yeah, sure. So my question is, you list like all the the downsides of the other two metrics, and I can see like what you did for yours, but then I'm curious about like the downsides that you discover for your own metric. Is there any?
So basically, actually, of course, we didn't do the study to just show the downsides of that. But the thing is that with our accuracy metric, we provided, as Dongwon already mentioned, that we tried to provide a guideline to use different accuracy metric for different intended use case. So basically, if this metric would be used or when it will be used for different intended purpose, then they could tell better that, okay, is there any downside? Because we proposed a metric we didn't evaluate on different intended use cases. So we have to wait for the drawback of this metric.
Yeah, fair enough. Yeah, thanks.
So Diego, do you want to ask your question to Lena?
Trying to can hear me well. So Lena, I think it's fascinating work. We've always tried to do in the lab, try to help maintainers and understand their impact and the changes that they do on their clients. So I have a question and a question even. So the first question is, in my experience, one of the most difficult types of breaking changes are the ones that happen without signature change, which is the ones that they change behavior either by mistake or they fix a bug before the behavior change and that breaks their clients. So is there anything on the horizon for Breakbot to maybe try to tackle this kind of breaking change?
Yeah, so that's an excellent question. So from what we have seen so far is that we have like 3 types of breaking changes, more or less, right? Like the binary ones related to the jars that we are generating or the binary code. Then you have the source code ones that are related to compilation errors. And then you have the ones you're mentioning, right? Like the behavioral ones. And those are the most difficult to detect. So with the first 2, you can actually use like static analysis solutions, and that one will be super fast to identify. But then the issue with the others is that you really need to run some code to actually see if the behavior has changed. In the case of Breakbot, we do not have like short plans for that. It's more like long-term plans. But the idea is also to rely on the test suite that you have with your libraries, right? Mm-hmm. So if you make a modification, what we do is that we run the test and we start checking if the tests are failing. Of course, the problem here is performance, right? And the other thing is that you won't cover all the code. So it will depend on the test itself.
Absolutely.
So these are the things that we are starting to check, but we are far away from having something stable or good.
I see. And real quick, just a quick follow-up on that. I think what we very interesting is to also help the clients that are migrating, let's say, a major version, right? Because the library maintainers, they will change the API now and then, and they change to a different major, but that may not impact your code as a client. So maybe Breakbot could work both as helping maintainers and just telling, okay, if you do this major update, you not break your code because you're not using the API that changed. So that might be an interesting way of
that's completely true. And actually in our future plans, that was the Dependabot + that we mentioned.
Okay.
So that's the kind of information that we also want to share with the client. So, okay, you have the latest version, you're afraid to migrate because you don't know if it will break your code. Look, you can do it easily because nothing is affecting you. So you can actually reduce the technical lag that you have with your own project. So that's for sure, that's a use of Maracas, which is the one that is behind Breakbot.
Awesome. Thank you very much. I'm looking forward to see.
Thanks for your question.
Awesome. So before going on to we'll circle back to the remaining question for Lena. I have a question for Saile. Don't know, are you still here?
Hi, I'm here.
Okay. Yeah, so, and I apologize if I missed this information. So I think you're trying to fix unreproducible builds for C-based systems, right? Is that correct? Like for the Linux kernel, but specifically, I guess, in general, C-based systems, right?
It's not restricted to C, but currently we work on, say, Makefile and shell-based build system. Yeah.
Mm-hmm. And is the reasons mainly like dependencies that are missing, or like what would be the biggest reason you found for the unreproducible builds?
That's a good question. Thank you. There are many reasons that may cause unreproducible builds. For example, the most frequently identified patterns is the date command built embedded in the file. For example, a compressed file, gzip, there will be a timestamp whenever you compress it, unless you use certain parameter. Also, there are some, file system metadata. When you use, say, find directory and output the file list into a file, and that list is not guaranteed to be reproducible when you do it on different systems. So there is actually a list of around hundreds of issues that may lead to unreproducible builds. In the reproduciblebuilds.org, there is a detailed list about the root cause. Yeah.
Okay, thank you very much. Yeah, that clarified everything. I guess so. So a lot of this is basically portability issues with the Makefile kind of details, right?
Yes.
Okay, got it. Okay, thank you.
Okay, thank you.
That clarifies. Okay. Okay, so I guess we can circle back to Domenico's question to Lena.
Yeah, actually, it's more of a philosophical / political question. It's so.
We want to end the session.
Yes, should a new version of a library have the right to establish a new contract and so violate the previous one? And of course, this can be done gradually. You can deprecate methods, you can announce changes in the API, and give time to developers. We know developers are lazy, and they will not update their application dependencies. But we have seen it, for example, in operating system. Someone decided to deprecate Python embedded a few years ago, and after 2 years, some applications were not updated. So, what do you think about this issue? And of course, Breakbot tried to mitigate this problem.
Yeah, so actually, I love that question because it was because of that question that we started developing Breakbot. So the thing is that when we start reading about breaking changes and backwards compatibility, like the general idea is that introducing breaking changes is always harmful. And what we have discovered like during these years is that maybe that's not the case. Like if you do not introduce breaking changes sometimes, actually your design will be obsolete at some point, and then you will need to re-implement the whole system, right? So what we want to do with Breakbot is just give the information to the library maintainers, right? Like you want to introduce a change, fair enough, but just be aware of what's happening, right? If you know that you will impact 80% of your clients, of your relevant clients, let's say, then okay, you need to pinpoint which are the changes that are impacting them and maybe design some strategies that will help them cope with that change. So it will depend on the library, it will depend on the ecosystem, right? It is not the same to work in this Maven environment than to work in NPM. In NPM, changes are being introduced like more frequently, while in Maven it takes a bit longer. And let's not talk about Eclipse, which really it's super like far away off, or it doesn't support or do not push to introduce breaking changes, right? So this is more like just to give the power both to the library maintainer and at some point with the Pendabot++ to the client developer. But that's a great question, I think.
Thank you for the answer.
All right, so we are 5 minutes away from the hour. So I know like some people might be going to other sessions, might need a water break or so on. So I'm suggesting we wrap up the discussion at this point. I don't see any further questions coming in. Thank you, Zoe, for the link related to the previous question. So I just want to thank everybody, our speakers, our participants, and all the authors' contact information is on the program. So if you have further questions and want to, follow up and ask them questions, please feel free to reach out. There's also all the socialized kind of channels. And yeah, thank you everybody for attending this session, and see you around.
Bishaki, am I still there? Hello, can anyone hear me? Hello, can anyone hear me? Hello, can anyone hear me? Okay. Can anyone hear me? Preferences, audio. I can't. Can someone speak? I can't hear anyone. Wow. Okay. Well, well then I know I can talk. Mute.